Hello, everyone. I'm Andrea Zinno. I work in Denodo, one of the leader company in data virtualization space. So we are working, we cope with data every single day. We are in within the topic of data integration, of which data virtualization is a new way to integrate, to use and consume data. This in my speech, I would say I will try to address the data integration from a slightly different point of view. Try to make an analogy with physical world to show it, to share with you what we consider the main points that putting together made a very good, agile, and modern data integration seems, because it's my feeling that in some cases we put, let me say, low attention to some points that are indeed very, very strategic in terms of effective use data and try to get value from them. So let me start with my first point is the analogy I was talking before. And the point is, in a digital world, the data are our eyes. So if in the physical world we observe the real world through our eyes, and this is, this is a very complex neural system supporting this activity. In a digital world, we are the data that are the bridge between what happens outside the company and what we can observe, and taking the decision based on what we observe through data. So this is my first consideration. And going deeper on this point, we need to. I hope that you are on the same page. That looking and seeing are two very distinct actions. The first one is a sort of physical activity. So if in the physical world we cope with eyes, and when light stimuli that are the light that are captured by our eyes, in the digital world we cope with data, and for the physical part we have to cope with syntax, with the way the data are represented, are stored, with the occurrences of data. So the collection of data we store about a specific concept. For example, the list of our customer, the product listing, and so on. In some cases, we refer to this kind of physical activity as the extension of a data of a concept. At the opposite is the seeing activity, that is mainly a logical one, that has to do with understanding, with semantics, because sometimes we see that you are looking to something, but really he or she is not seeing what is looking to, because the different part that address the seeing phenomena is made by understanding. So it's a very mental activity. And talking in the data terminology, that means that we are taking care of the semantics of the data. So how the data is represented, what is the source, how they are modeled together to effectively represent the world on which the company is acting to. And in some cases, this is referred, as the intentional component of a concept. So when we talk about data, we need that any data integration solution should be able to treat and to cope with this very different aspect. One of the key points, not only of the data virtualization, because I will address this point in the next slides, but I think this is a very common point, is what we call a logical physical separation. That means that when we cope with data, but basically when we cope with the real world in our day life, in our day-by-day life, we have a very different moment. And here the example I've made is that of a library. When we go to a library with a specific idea, specific needs, we basically do two very different things. The first, that is the logical part, is to take a look at the catalog of the library, just to check if the library has everything I need to address my needs. So for example, I need to make a research on data integration. The first thing I do is to open the library catalog to see what kind of publication or books are on the topics. Normally, what happens is that I don't find a single books or a single material that address my needs, but I have to collect different publication or books, taking some content from one of them and other part of content from the others. Just only after I understand correctly the type of books or material that I need, I can move to the physical part and going directly to the shelves or asking to someone that is there to help me to effectively collect to collect the books at the publication, because I have to put them on my desk and try to start to do what I have to do. And this is basically the logical physical separation. The same things happen also with data. When we have a goal in our mind that could be to set up a predictive model or to make some reporting, some dashboarding, we start from data, but the first thing that we need to do is try to understand if the data that I need are available in the informational assets of the company. Just as a final step, after I completely understand what I need, there is the physical part, as I said before, that is basically to collect, in the library example, to collect the books from the publisher, or in the data world, to collect the data from the data sources. This type of separation has in our opinion, a lot of benefits. Here I will list just three. That the first one is that if I don't collect the book in advance, because here the idea is a sort of a new generation library, so a library that doesn't collect in advance all the books, but let me say, request the books directly to the publisher when I decide which kind of books I need. In this case, so for the next generation library, the benefits are, I think, quite obvious. First, I can reduce the space needed to store the books, because yes, I have to take care of the logistic part, because I request the books quite often with respect to a classical library. But I reduce enormously reduce the space needed. The second point is about the freshness of the information. If I request the books to the publisher in the very exact moment when they are needed by someone, I resolve any problem related to different version of the books or whatever. The last point is the overall optimal management, because don't having to collect the books in advance, I avoid the risk to collect books that are never requested. And this is typical also in the data space. If I build a unique repository, physical repository, and put in them all the data, then could happen that some of the data I have collected was never investigated by anybody. So I spent a lot of resources, a lot of time, because I have also to keep data aligned for data that are never requested. And this is basically, I said before, the essence of data virtualization. Data virtualization means to integrate data, taking care of this kind of separation. But going back on this in a couple of slides, because let me say, the separation itself is not enough. We need also to guarantee some characteristics that are very important for an agile and modern data integration. And we can split these characteristics again in the physical and logical part. So for the physical part, we need to reach the data regardless of how they are made or where they are. And also we need to be being able to represent the data according a common model, because one of the key points about data is the sharing of the data among different people with different skills. So we need to simplify the data representation to allow everybody that is working on the data to not to have a very specific or technical skills. From the logical part, we should have a centralized data catalog. I mean an active data catalog. So not only a catalog that describe what the data are, what they represent, but also a catalog that keeps the connection between the meaning of the data, so the logical part, with the place where the data are really stored. So with the physical part, because the real value is in the connection between the two different parts. In the logical part, we need to make very simple to connect data together, as in the library sample. Very rarely we find a single data that is address our requirement. Quite often we need to collect different data and collect and compose them together to represent a more rich context, a more rich entity. And last but not least, to make sure that the source of the data is evident, because this is a matter of trust, because we need to know every data where they come from, because we need to be sure that we are using data that are in quality, that are certified, and so on. And this is basically the goal of modern data integration, to be able to let the people concentrate on what they have to do instead on how to do what they have to do. The very essence is that, let me say, the main goal that we should have in mind in designing a data integration system is that we should be able to perform different activities with ease. We don't have to spend too much time to learn a new language, a new representation. We need to be concentrated on the meaning of the data and to collect data very rapidly. So here I've listed a lot of sort of different area where the concept of ease applies. So easy of understanding, ease in combining data, ease of adding new data if we don't find what we need, and so on. So this is a very important point. And we can also define a sort of very simple formula to define what is. And in my opinion, is the sum of agility and intuitiveness. So we need to have a system that allow us to move very fast. And this just because the outside world is moving fast. So we need to react very fast to any change. We need to be able to adapt to a world that change is shaped very frequently. So we need to be liquid in some sense. Quite often we talk about liquid company, liquid and non-viscous company, because the capacity to be agile and to adapt to the world is a very key one. And at the same time, we need to perform all the activities that we need to perform with in a very intuitive way. as I said before, we cannot require any people that have to cope with data to learn new skills because there are new data to be represented and so on. And this is a very key point. And basically, all the things that I mentioned in the previous slide, so the separation, the agility, the intuitiveness are basically the key point of a data virtualization system that can be synthesized in this slide. So it's a very simple one. Basically, make a data virtualization system would be to create a new decoupling layer between the data layer and the business users.
Ciao Matteo, come stai?
Sorry. Someone else opened the mic. So to insert this decoupling layer and to perform these 5, let me say, big steps. So the first is to be able to access all the data regarding whatever they are and wherever they are and whatever they are made of, and through an abstract. Can you hear me? There were some problems.
Yes, I apologize for technical problem.
Okay, so I don't know how, up to where you heard me, but I was just make a recap on data virtualization. I highlight the 5 main points. The one is to be able to access any kind of data, wherever they are and whatever they are made for, through an abstraction operation. So that means that all the data will be presented to the data steward or to the one that are taking care of data modeling with a unique format that in our case is the relational one, so made of table and link between table. And this is independently on the original format. The second one is to make data available to any kind of data consumers, being them application or human or analyst or whatever. Doing that on demand in real time or right time and with zero replication. The point 3 and 4 are the very key point of data virtualization. We don't need to replicate or copy data just to make them available to someone. This means that we will take the physical part of the data in the exact moment when the data are requested. The last point, last but not least, is all the additional functionalities that a data integration system must offer to be compliant with the ecosystem on which the data integration is integrated. So we need to be compliant with security, with authorization. We need to offer very good performance, and basically we need to be able to control and govern the entire system. And this is the point. As a next step regarding the data virtualization is that how can we use the data virtualization is in a, let me say, more broad concept of enterprise data fabric. You know, is a very modern way to look at data that is based on very strong, deep interconnection between different data. And the idea is so to having any kind of data sources, any kind of data consumers, is to create this intercommunication layer that allow to bring any data to any consumers, offering some specific functionality, so data abstraction, logical view, this is the separation, the security, and so on, at using the data catalog as a key point, as a unique access point to all the information assets that are available in a company. I just spend my last 2 minutes just for a specific kind of data source, that is the data silos. That is something we heard about tons of time, and this is something that someone would like to destroy, but in our opinion, this is probably absolutely not the right move to do, because, you know, a silos protect its content. So it's not something that has been built to segregate the data, but to protect them from use that should not be done. So here the key point is not to destroy data silos, but to connect them with the other data sources that are available. So in our view, in a very modern data fabric approach, the idea is to use again a local virtual layer for the data silos, so to make the data contained in a silos through a data virtualization layer, and use this new, let me say, ecosystem that is made up of the silos plus the virtual layer as a data source for the enterprise level data fabric. So we keep the data secure in the silos, but at the same time, we make the data available following specific rules to anybody that needs them. And this is basically the idea of data virtualization in a more broad space, and specifically that of enterprise data fabric. So let me conclude. So here the point is that we don't need more data. We have tons of data. Probably we have enough data to address everything we need to address. So here the key point is to have a new way of seeing, that is, in the digital world, there is a new way to use data from the moment they are collected to the moment they are used. We need a very harmonious and homogeneous way to treat the data along the entire life cycle. Sometimes our feeling is that we lose, we like to concentrate on a specific point on that life cycle. So for example, the presentation, the visualization, given as assuming as it was already addressed and some points that in reality must indeed further investigate, like the universal semantic model, the unique access point, and so on. So this is my these are my conclusion. So thanks again for the attention. I don't know if we got some questions.
Yes, yes, Andrea. Thank you so much for the presentation, and I apologize everybody for this 5 minutes delay we will have. So we will have the panel discussion 3 minutes later. But now there is an interesting question from Thomas Bode from Swarovski, referring. You see the question there as well, Andrea, on the chat box, referring to slide 8. Yeah, if, Andrea, you can go to slide 8. Could you explain further how you recommend to handle the transformation layer? And do you think that there is really an opportunity to perform all required transformation for BI and data science without persisting data?
This is a good point, probably a very complicated question. So I am available also offline to make more information. The idea is in the virtualization layer, that is, I said before, at the coupling layer, you should concentrate any activities on the data. I mean, so when you gradually connect all the data sources, normally you have the needs to compose more articulated data. So for example, take the concept of customer. This is normally made up by very different data sources. You have to connect the customer care, the sales system, the marketing, and so on. And in our point of view, you should operate this kind of transformation within the virtualization layer for the very basic reason that everything that is available in the virtualization layer is immediately available to any kind of data user. So the data scientists, but also a mobile application, but also a backend application to perform what they have to perform. So here, the idea is to reuse any informational assets for very different use. So as more data are present in the data virtualization layer, more they are reusable from among different business users. So I don't know if I answered because then let me say, the concept of persistence, here the key point is that not that in the data virtualization approach you don't have to make any persistency of data. The idea is that you need to avoid to make, to replicate or to copy data just for a data integration needs. Then you can make your data persistence, for example, for data scientist activity, but this is a very different aspect.
Exactly. So thank you so much for the answer, but the purpose of this meeting is really all about this interaction and communication together. This is why we have a panel discussion after you. But I would like to ask Thomas Budde, because Thomas is there still. Thomas, if you got the answer, you can still use your microphone because you are co-host. If the answer was okay.
I'm here, Mohsin. Yeah, I mean, we could have a long debate with Andrea, I think.
Yeah.
Yeah.
You are welcome.
Okay, so
yeah.
I hope you will have the opportunity to speak together later during the breakout session of afternoon, which will be easier and smoother than that of morning. Thank you so much, Andrea, for the presentation.
Thank you, Nassim. Thank you, Thomas. Thank you to everybody.
Thanks a lot. I would like you to stop.